Welcome. Thank you for joining us for our water webinar, Tips and Tricks for Water Samplers. If you have any questions during the webinar, please use the chat or Q&A functions within Zoom. All questions will be answered at the end. This webinar will be recorded and a video will be made available in the next few days. Our presenter is Jeff VandeHoef, Product Support Specialist. With that, I'll turn it over to Jeff.
Thanks, Sharon. I'm here. Can you hear me fine at this point?
Yes, perfect.
Okay, we're good to go. Welcome to the webinar today. My name is Jeff VandeHoef. I'm going to be the presenter today. I am a product support specialist here at Teledyne ISCO. I've been with the company going on 30 years. Last 5 years, basically been in product support services, talking with people on the phone, helping with application questions, any type of programming with a lot of our equipment here. Today's webinar is going to be over sampler selections, basically just kind of different types of samplers out there on the market, things you need to consider when you're actually selecting a sampler, as far as, even power, site conditions, options you need, that kind of stuff. We will get going here. So one of the first things you usually want to consider is, what type of sampler is this going to be? Is it going to be a permanent sampler or is it going to be, a portable sampler? Permanent samplers a lot of times can be large, kind of refrigerated type samplers. These samplers usually have like a pump and a distributor mechanism built right into the refrigerator themselves. The most common applications we see with these types of units is in like wastewater treatment plants, influent and effluent locations. We see a lot of these in industries where they are monitoring, the discharge of the water and everything like that. For portable samplers, are usually, quite a bit smaller, lighter, easier to move around from site to site. Common applications we see for portable samplers includes like in manholes, rivers and streams, stormwater runoff. We even see these in like wastewater treatment plants and industries. They use it for process, point monitoring, for monitoring a certain point of a process, or even really, discharge. If you don't require refrigeration, then you can have, the portable ones pretty much anywhere you want. Another good thing to consider is what are you going to have for a power source, at your site. Most permanent applications will use, an AC power source. The refrigerated units that we have out there are going to need an AC power source. The refrigeration on these units are similar to, like a household refrigerator. They really require too much power to run effectively, off of a DC power source. So we do have to have AC power source for, most permanent type ones. Some of these units are also like all season refrigerators. They can be located inside the plant, outside the plant, really doesn't matter. So if your sampler is going to be outside, your plant or outside in the weather, you make sure that, the sampler you choose is going to be rated for that. Portable samplers can also be used, in permanent applications as well. If you don't require refrigeration, then you can use a portable sampler with an AC, to DC power pack. For true portable, temporary applications, the samplers will use some type of battery as the power source. The two most common type of batteries we see used in these applications are either lead acid or NiCad. NiCad stands for nickel cadmium battery. It's a very popular type for like power tools and that kind of stuff, batteries. We have advantages and disadvantages for both lead acid and NiCad. So it really kind of makes a difference for which you choose for your site. Biggest advantage for lead acid battery is that they generally are more powerful and last longer than the NiCad. Disadvantages for those are you can't discharge a lead acid battery all the way. If you fully discharge it back down to, like 1 or 2 or 0 volts or something like that, you can actually harm the battery. So you really don't want to discharge it to all the way to site. So if it's the site that you can't get to in time, and it's probably going to keep there and stay there and keep running, then you probably don't want to do a lead acid, because it could damage the battery if it does drain down to nothing. Also, they're not quite as effective in cold weather either. If they're in cold weather, it's basically a lead acid battery, just like what's in your car. They just don't quite work as well. NiCads, on the other hand, they perform better in cold weather. You can actually get more charge and recharge cycles out of a NiCad battery than you can a lead acid. You can also totally discharge a NiCad battery, and it's not going to affect the battery at all. They actually perform better if you do fully discharge a NiCad on every use. The main disadvantage of a NiCad is they have a lower capacity, so they just won't last as long out in the field. For both lead acid and NiCad batteries, a full charge takes about 16 hours. We get a lot of people, charging batteries for only like 12 hours or something like that, and then the battery slowly starts to not perform, what they want to do. So you definitely have to charge them at least 16 hours. Another question we get a lot of times is, can I store the battery on the charger, so it's ready to go? NiCads or lead acids, probably should not be stored on the charger. You can overcharge them, and that can, damage your batteries. If you have an automatic battery charger, that does shut off when it reaches full charge, then that's okay. But if you don't have an automatic charger, then 24 hours is probably the max time I would ever want to leave, a lead acid or a NiCad on the battery charger. So. Permanent but remote locations often use like a solar panel with a deep cycle marine battery. More power than needed usually beats not enough. You definitely want to err on the side of more power than not enough power, so you don't miss your samples. I usually recommend like 100 amp hour, deep cycle marine type battery. 100 watt solar panel is always good. Solar panels nowadays are pretty cheap out there. You can get a 100 watt one, fairly cheap. The 100 amp hour, the deep cycle marine batteries, you can get those batteries, Home Depot, Menards, any auto parts store, basically, where you can get a car battery, you should be able to get, one of those batteries. Same is true, for temporary locations that are going to require a lot of power too. A solar panel with a big 100 amp hour battery like that, it's definitely going to get you through your sample routine. So. What bottle configurations to use? Some samplers are pretty much composite only samplers, which that means is you can only have one bottle in the unit at a time. Only fill one bottle. Typical sizes we see for the composite type configurations are usually 2.5 and 5 gallon. They usually have glass or plastic in both of those. So. Multiple bottle configurations. Some samplers actually can be configured for single bottle or multiple bottle configurations. So sometimes you can switch back and forth between the two, and again, that's all dependent on the manufacturer and the model. Typical ones that we see out there are 2, 4, 8, 12, 24, sometimes even 14 bottle ones I've seen out there as well. Yeah, again, they are manufacturer model dependent, so make sure that the model that you're getting will support, what number of bottles you need. Again, there are glass and plastic bottles available for single and for multiple bottle configurations. Again, manufacturer model dependent. A note here a little bit, we see a lot of sampling for like PFAS type sampling. You don't want to use a glass bottle, I think, when you're doing sampling for PFAS type chemicals. So. What are your site conditions? Do you have a high vertical lift? Vertical lifts on units can vary anywhere from 23 feet up to 28 feet. 28 feet is the max for a vacuum pump to pull up a sample. It's basically the max for everybody. It's a physics thing where, you know, you can only pull water straight up with a vacuum, you know, 28 feet. No matter how powerful your vacuum is, you can only go 28 feet. If you need more than 28 feet, there are booster pump options that'll let you do the vertical lifts greater than that. Basically, the booster pump will go down lower, you know, closer to the water, and that will actually push the water up to your pump, and then the second pump actually pulls that water, you know, from there with the vacuum. Another thing you want to consider is what is the distance between the sampler and its source. This is to determine the length of suction line you need. Most peristaltic pumps that are out there, that's the pumps with the spinning paddle and the tubing, the soft medical grade tubing, silicone tubing that's inside there. Most of those are limited to about 99 feet. They can go that long, but I probably wouldn't recommend going that long on a peristaltic. You know, 25 foot or under is probably the optimum length that you want to do there. You always want as short as possible. With that, you actually you will have less wear and tear on the pumps and on the tubing. And you know, the shorter the suction line, the less often you're changing those things, and you know, less maintenance and less babysitting this thing's going to need. Vacuum samplers out there, there are actually vacuum samplers out there that they don't have a mechanical pump like that. They work with just like a little AC motor vacuum pump, and those actually can have line lengths greater, you know, up to 300 feet. And you don't have to worry about changing tubing or pump tubing or anything like that in there. So if you have a really, really long suction line length where you got to go, you know, over 100 feet or 200, 300 feet, then you definitely want to consider a vacuum type sampler for that. Sampler source conditions, things you want to look at is the depth shallow. For shallow depths of your water, the water you're actually sampling from, we recommend some type of like a low flow type strainer. Low flow strainer is just a very small diameter, you know, piece of pipe or with holes in it, some type of strainer that, you know, is going to let you take water from a, you know, a smaller flow, like an inch or 2 inches of water. If you have high velocity in the flow in the stream, then you probably want some type of weighted strainer to help keep it in place. If the weighted strainers aren't enough, then you may have to actually, you know, affix it to the bottom of the channel, side of the channel, you know, wherever you're actually, you know, sampling from. So it's not uncommon that you have to do that. I've seen people, you know, throw a cement or tie it to a cement block, throw it into a river or into a channel or a stream like that. Basically, they put it on top of the cement block, keeps it above the bottom of the channel so you don't get sediment and stuff like there. But if you're looking for the sediment, well, then you put it down closer to the sediment. It's just really dependent on your site, your conditions, and, you know, what you're sampling from. So you definitely want to keep the strainer, you know, in place. So. Here's some actual setup recommendations when you're actually taking your sample to the site and actually set it up. You always want a level surface to sit the sampler on. If not, you know, the sampler could roll away in wind or whatever like that, or it can actually, in like a multiple bottle situation, if the sampler is tilted, some of the water actually may tilt and, you know, drift off to the side and actually not make it into the bottle. It's a very common thing we see when you have them in manholes. You're kind of hanging them in a manhole and suspending them. We definitely want to try to get that as level as we can. That way it actually hit, you know, all the bottles. If it's a composite situation with only one bottle, you know, we're less concerned with level, but it always is nice. It always helps for filling the bottle. Again, we always recommend the shortest suction line you can. Definitely want to shortest we can do it, just we want to avoid wear and tear on the pump and the tubing. So, and again, that's just with the peristaltics. A natural slope to the suction line is always a good thing. This is so that the water clears out of the tubing completely on the purge cycles. If you have high or low spots in the line, it can cause water to pool, and then it can cross-contaminate, you know, the different samples. I like to have a natural slope all the way down from the sampler all the way down to the source. So even if you didn't have a purge set up on these, it actually still drain the water naturally. So Yeah, sometimes people have to go where their source is up higher than the sampler. That can cause problems with liquid detectors and stuff like that. So that's kind of not recommended. If you do that, then you're always going to have water in the line, and then you will get some, cross contaminations if your source is higher than your sampler. Shade from sun, that's always a good idea. Don't want to have it directly in the sun, cooking the samples that you're taking. Sometimes people put ice in the middle of the bases around the bottles to help cool the samples quicker. That if you put it in the shade, it'll definitely help that ice last longer, be more effective for you. With refrigerated samplers, it really helps the refrigerator actually perform better and cool off your samples quicker if it doesn't have to fight, the ambient heat of the sun radiating on it and stuff. Is there a need for any other peripheral devices or, associated equipment, anything that's going to interact with the sampler, to tell it when to start, when to stop sampling like that? Some of the most common things we see out there are modems. Modems provide remote control and remote access actually to the sampler. You can also alarm with text messages and stuff like that for problems or events. You can call into the unit, you can change programming, you can say, sometimes you can just send it a text message and say, okay, start the program. You can send it another text message and say, I want to take a sample right now, no matter what the program is doing. A whole bunch of stuff that the modems actually let you do with those. Another option is an SDI-12 communications. It's SONS, usually will speak SDI-12. Just a communication protocol is what it is. There are different SONs out there. YSI makes a SON. The different SONs out there, they actually read like PSI, dissolved oxygen, turbidity, temperature, conductivity. There are samplers that will interface with those SONs, and then you can actually sample based on all of those parameters. When my pH it goes over 10, I want to start my program. I want to actually start sampling everything like that. A very common thing to do. You can do it off of any parameter, pretty much it reads temperature, conductivity, turbidity, whatever the sensor reads, you can usually trigger the sampler, based on those parameters. There's things out there called liquid level actuators. Basically, that all it is a liquid sensor. Basically, water kind of rises up to a certain point, hits the actual tip of the sensor. Once it sees that there's water in the channel, then it enables the program, lets it start running the program, lets it start taking samples at that point. When the water goes away and it's not touching the end of the sensor anymore, then it'll disable it and say, nope, I don't want to take any more samples. Don't want to take samples if you don't have actual water present in your channel stream or pipe or whatever you're sampling. Rain gauge, you can interface the samplers with rain gauges. You can actually trigger from rain event. This happens in stormwater monitoring quite a bit. In the desert or wherever they don't get rain a lot of time, basically they don't want the sampler running. So they wait, have a rain event, boom, you can start taking your sample right away once that rain threshold's been met. Other samplers, you can actually have flow modules that actually plugs right into the sampler. So it's kind of like a sampler / flow meter combo all in one unit. There are different modules out there. There's like a pressure model, measures level only, area velocity, measures actual level and the velocity in the pipes, calculates the flow rate from that. There's bubbler modules that read the level and then calculate the flow rate. There's also like analog input modules. So that could take like a flow signal from, a different flow meter out there that outputs the 4 to 20 milliamp signal. And you can actually input that into the sampler and trigger and sample based on that as well. There are other functions out there and stuff too. If you have something specific, just get with the manufacturers. They can definitely help you, try to interface your device with the sampler if you need to. So program features, time or flow-based samplings, they're the two kind of modes that you can do when you're actually trying to take samples in programming your samples. Time-based samples, there are different ways to do time-based samples. The most common is like a constant interval sample, which means you're taking a sample every 15 minutes, every 5 minutes, every hour. That is user selectable. You can take a sample, whatever you want. The next one was non-uniform time. Non-uniform time is actually if I want to take a sample, my first 5 samples I want to take every hour. So 1 o'clock, 2 o'clock, 3 o'clock. Then at 3 o'clock is when I get most of my flow. So at that point, I want to start taking samples every 15 minutes. So then I want to take one at 3:15, 3:30, 3:45, 4 o'clock, 4:15, and so on. So you actually enter the time that you wanted to actually take the sample. That's for non-uniform time. There is a function on some samplers I've seen. It's actually a random time interval. Haven't seen it used very much, but you can actually, the computer or the sampler actually generates random times, and it just takes samples based on random intervals. My first sample might be after 5 minutes. The next one might be after 2 minutes, then maybe an hour, then maybe 15 minutes. It just kind of generates random intervals for you. Typically, what we see here are a typical program we would see somebody running in time paste would be like every 15 minutes, which calculates out to about 96 samples in a 24-hour period. That is the most common program we see people running, by far. Here's a chart example of a uniform time paste sample routine. Every 5 minutes, we put a set amount of water into a bottle. You can see the flow here, high flows, whatever flows, it doesn't make any difference. We're always taking a sample every 15 minutes, putting that exact same volume into the bottle. Flow pasting samples. If you're flow pasting a sampler, the sampler needs to be the sample that you collect in the end needs to be representative of the actual flow for that day. So it has to be basically a representation of your flow for the whole day. This gets a little bit more complicated when you're trying to set up a flow paste sampling system. You need to know more than I want to take a sample every 15 minutes. The things we need to know to accomplish this is number one is what is your sampler that you're using. We usually need to know this so we can figure out what type of connection options to use, to actually bring in your flow signal to the sampler. If you're using like a flow module and stuff like that, well, then that's all built into the sampler, and then you don't need any connections or cables like that. Flow meter. Another things you really need to know is what type of flow meter that you're actually bringing the signal in from. What output signals does that flow meter have? Common ones that we see are a 4 to 20 milliamp signal. We have active high voltages coming out of them. We have a contact closure, and there are other forms as well too. We call all of those flow pulses. So from a 4 to 20 milliamp signal, we can convert into flow pulses. An active high is just a voltage that comes out. A 5-volt voltage comes out, says every single time, that's a flow pulse. Contact closure is just shorting 2 pins together. Again, we need to know what type of input we're putting in there so we can figure out your cabling and your interfacing, cables that you're going to need to get that to work. Information you need to know in order to program your sampler for flow paste samplers. If you're doing a 4 to 20 milliamp signal, we need to know what the scaling of that 4 to 20 milliamp is. Once we know the scaling of that, then we can actually figure out what each pulse that it's going to convert to, is going to be. We can figure out, what it is in gallons, and then you set up your sampler for pulses. So definitely you need to know what the scaling is. So on a 4 to 20 milliamp signal, 4 milliamps, if it's outputting, is usually 0 flow, and then 20 milliamps is going to be your max flow on that. So we definitely need to know what that 20 milliamps or your max flow is on there. If you're doing a pulse output, which is like a contact closure, or if it is like a constant or a high coming out of there, we need to know what that pulse output represents. That's usually all programmed into the flow meter. The flow meter, you can actually program it to say, send a pulse out every 500 gallons or every 100 gallons. That's usually all programmed in the sampler, or I'm sorry, in the flow meter. In order to figure out your sampling routine, as in like how many samples I want to take, how much sample do I want to take every time, we need to know your daily averages for your flow. We need to know the minimum flow rates that you ever get, and we also want to know the maximum flow rates that you ever get. This can help you determine how many samples you want to take as well. You definitely want to know how many samples you take. So if we're taking 100 samples, and we have our total flow of 1,000 gallons, you take 100,000 gallons divided by 100. So then you're probably going to take 10 samples in a day. A normal target is, again, kind of like what we said before, the 96 samples, which a time-paced sample is going to be every 15 minutes. But with a flow-paced program, you just aim for 96 samples. So you take your typical flow for the day, whatever that is in gallons, divide that by 96, and that would tell you how often you want to take a sample. So if it was every 1,000 gallons and you wanted to take 10 samples in the day, then you're going to take a sample every 100 gallons. When you're figuring out how much volume you actually want to have, your target volume in the bottle, we'd like to get it about 80% full. So on an average day, you're going to see 80% of that bottle full. You're still going to have 20% to work with there on a high flow day, so you can actually get a little bit more sample on a high day. If you got a really low flow day, well, then you're probably going to get a little bit less than that 80%. So basically, it just gives you a little window, plus or minus, so you don't overfill, or at least you always have enough sample, or you don't overfill your sample. Here is an example of a flow-paced sampling chart. So you can see down here at the start of the graph at 12 o'clock, we actually don't have any flow, and we have not actually taken any samples. Right here about 12:30, we start getting flow. Oh, we have to take a sample here. Flow goes down, we don't take any more samples. It kind of just follows the flow. When we get flow, that's when we take samples. We get a really high flow event, like right here, then we're taking a whole bunch of samples right when the flow is here. So we're pretty much only concerned with taking samples when there's actually flow going by. And then we don't take samples, of course, when there's no flow going by. Nice little graph there. And that is pretty much it for the program. We have questions on there. I don't know if we have any questions showed up there, Sharon.
Actually, we do. We do have a question. Let's see here. In order to maintain shade over the samplers, do you recommend something similar to the carport cover?
Yeah,
or
go ahead.
Let's see, or an enclosed shed with vents for some airflow. Which do you prefer?
Either or. The closed shed, you'll see those in like cold weather situations where you definitely want to keep it warm when it gets cold outside. Sometimes if that's in direct heat, you can get actually hotter inside those sheds. If they're not vented. But just like a sunshade, like a carport thing, yeah, that's great. That's fine. We see that a lot. Sometimes just like an L-shaped bracket. Something like that, just to shield it basically from the highest, direct sun of the day. So really, pretty much any way you can get it in the shade is a good thing. So.
Okay, let's see. We also have, is there a brand of voltage regulator that you recommend for the deep cycle marine battery and solar panel setup? So,
most solar panels actually have regulators built in there to them to protect the batteries that they're charging. A lead acid battery, you always have to use a lead acid battery, deep cycle marine, same thing, on a solar panel. And most solar panels have that regulator built into them. So you really don't need an additional regulator for there. You don't want to go over about 14 volts when you're charging a lead acid battery. Yeah, really we actually have a different type of regulator that we can sell if the regulator actually goes bad in the solar panel. You don't want to have to replace the whole solar panel, but a lot of times you can get replacement ones from the solar panel company too if you need that. But really, no, any any 12-volt type regulator is fine. Basically, we want to limit it to right about 12 volts, out of the battery or to the battery.
Okay, we have a comment. Liquid level actuator sometimes acts like it is inside water because some drops of water at the tip.
Yeah, sometimes on the liquid level actuators, if you're getting drops of water, there's like a rain shield actually that goes on those liquid level actuators that actually shields it and doesn't let it get rain on there. That's probably something that I would want to call our tech support guys with. They could probably help you out with more, specific application type questions. But definitely you want to try to keep that as dry as you can. You have like some type of shade over the top of that so it doesn't get rain or splashing water. You definitely want to make sure it's the water rising that's hitting, the sensor. So.
Another question, what is the maximum distance from the sensor to the AV module?
So that is dependent on the model. A typical lengths that we see are like 33 feet, 10 meters. There are ones that go up a little higher than that as well. I think the maximum length for some of our samplers, I can only speak to our flow meters here, are for like a 350 area velocity sensor. It's around like 200 feet, somewhere in that range. If you're talking like an ultrasonic, you can go quite a bit longer on an ultrasonic. You can almost go even up to 1,000 feet on some of our ultrasonic sensors. So it really depends on which type of sensor that we're talking about. Area velocities are a little bit less because it's a little bit of digital information going in there. 100 to 200 feet is probably max we see on those. So.
There's another question. Can you answer a question about the 2150 water speed module? But they didn't provide me any further information.
Yeah, if you have specific questions about some ISCO equipment, there's a number you can call. It's 866-298-6174. Again, that is 866-298-6174. That is our product support specialist. They can ask and answer, they can answer any of your specific questions on any of the models of flow meters or samplers that you have. So.
Another question, why is glass bad for PFAS sampling?
Yeah, I've heard that is bad for that. I am not a chemist. I really don't know the answer to that question. I would want to check with your laboratory personnel or a chemist out there. They would be able to tell you that answer. Yeah, chemistry is not my specialty, that's for sure. So.
Another question, if sampler must be lower than source, what would be the best recommendation for setup?
So in that case, there's liquid detect sensors that are built into these units, and there's always an option to turn off that liquid detect sensor. So you probably want to turn it off. You are going to get a little bit of cross-contamination on there. There's just nothing we can do about that. If you have a really high head height, so there's going to be actually build up of pressure in the line. There are pressurized line systems that you can actually do too. That there's like valves in there that actually reduce the pressure in there. So you can, sometimes actually purge the whole line out. Pretty much, yeah, the best recommendation is just to turn off the liquid detector and to make that suction line as short as you can. That way you're only getting maybe a little bit of cross contamination, between the two. Sometimes you can put valves in there or like a flow through chamber where it actually pumps the water, to a different source, and then there's a drain coming out of that source. It's kind of like an open, tank or trough, and then we sample from that open tank or trough. That way we don't have a head pressure on there, and that way we're able to set that sampler higher than the trough, so you don't actually have that. So yeah, some type of flow through chamber would be good for that too. So.
Kip requests that we explain flow pacing to samplers. 360 sampler interface cable via signature flow meter. He just wanted more clarification.
Yep. So so you can. So he's talking about our signature. It's an ISCO product. Our signature flow meters, and the 306 is our sampler interface. You can actually have a 306 sampler on there. If you want to do more than one sampler with the same flow meter, which the signature and the 306 are capable of that, you would actually have to have two 306 modules. You put two 306 modules on there, and then you set up an equation inside the flow meter, and you say, okay, I want it to tell the sampler to take a sample every 100 gallons, every 200 gallons. There's also features that you can do in there with enabling and disabling the samplers. You can say, okay, once my flow rate is above 1,000 gallons per minute, I want to start my sampling routine. You can do stuff like that. But yes, if you want to do two samplers with one flow meter, for our signature models, you would have to have two 306 sampler interface cables. Other manufacturers, other models may have Y cables and stuff like that. Some of our older stuff, I know we used to have Y cables, but pretty much now on the new stuff that we have with signature, you just have to have two 306 sampler interface. You can actually have more than two if you want as well. So.
Berhane question, is there any way samplers could keep on taking samples without purging back and forth? Is there any way sampler could keep on taking samples without purging back and forth? Why do I put time interval when liquid actuator controls sample?
So there are some samplers out there you can actually control the purge count. So you can set those down to like 1 or 0, so it doesn't ever do the purges for you, and it just does the pump routine. So it skips the pre-purge and it skips the post-purge, and it just does that. Those are definitely model dependent, model manufacturer dependent. If you need to do that, make sure to ask that question before you actually get your sample. But yes, you can do that on some models. As far as liquid level actuator, it's basically kind of like an on-off switch. When that turns on, when we have water at that sensor, that basically flips the switch and tells the sampler, start running your program. Your program that you're going to be running the sampler, it could be a time-paced program or it can be a flow-paced program. Basically, it just allows it to start, counting down the time till the next sample or counting down the flow to the next sample. So it's just kind of like a start and a stop for your program is what it is. Once the program starts, it takes off and does your time or your flow-paced sample. So I kind of like start and stop is how I like to look at it.
Russ questions, are there other tips to prevent overflowing the sample bottle during high flow events?
So that's where knowing what your flows are during the day is very important. If you know what the max flow is that you ever will get, then you calculate the number of samples and how much sample you want each sample, based on that. If you don't have a clue as to what your flows are during the day, it's kind of like a trial and error process. You run your sampling routine one day. If you get too much flow in the bottle, well, then you say, okay, I want to take a sample after 1,000 gallons instead of 500 gallons, and you just kind of go up and down. There's different ways to accomplish that too. You can say, okay, each sample I take, instead of being 500 mils, I want each sample to be 400 mils, and then you'll get less volume in there as you go. You just kind of a trial and error. But if you know your flow, that's the key thing. If you know how much flow you have in a day, you should be able to calculate and never overfill or underfill your bottle, as long as your average and your min-max daily flows stays true. If you get a really high flow day and it's over anything that you've ever seen before, well, then you're probably going to overfill your bottle. So yeah, it all really depends on knowing what your flows are for the day.
Another question, is it possible to sample for bacteria with auto samplers? Given when the water passes through the pipe over will that be acceptable for EPA bacteria, E. coli, fecal, etc.?
Yeah, I mean, with the suction lines, you can get bacteria that grows in there. That's a pretty site-specific question. Yeah, if you're getting bacteria in the pipe, then yes, it's going to be harder because you're going to have cross-contamination for the bacteria. We do have Teflon. There's Teflon type suction lines that are out there that doesn't let anything stick to it, and they help with the bacteria growth and stuff like that. So you'd probably just have to, you know, get different types of suction line and stuff like that to get that. Changing your suction, your pump tubing is a lot. You'd have to change that a lot more as well because you don't want to promote bacteria, you know, growth that's in there. But yes, some people do sample for that kind of stuff. It's just probably a little bit more, you know, maintenance and stuff. So.
Doug questions where he can find more information on the booster pump.
Yeah, the number I gave out before, 866-298-6174, definitely you can call that number. We can give information for you there on booster pumps, or just, you know, contact the sampler representative, you know, whoever it is, you know, directly, and just see if they have those types of options. Not everybody has those options, but I do know, you know, more people do have those. More than one manufacturer does have those options. So.
Ryan questions, what kind of enclosure would you recommend for a permanent site to help mitigate vandalism?
Usually some type of cover over it, like a little shed or something that you can lock the door on it. That's for the permanent site ones. They can sit outside and everything like that in there, but again, vandalism, stealing, that kind of stuff does happen. I know most of the refrigerator type samplers do come with locks, or you can actually padlock the door so they can't get in there. There's covers that will actually go down over the control panel and stuff like that, that keeps people from vandalizing like that. But yeah, definitely some type of hut or enclosure that you can lock the door is definitely going to be the best for there. So. See one here. Do you consider to supply 5800 with battery and solar panel? Nope, that's kind of what I said in the presentation early on. You do not want to run a 5800 off of that. Any type of refrigerated sampler like that, it basically just draws way too much current, and you're just going to drain your batteries. The process to change a DC current into AC is a very inefficient process. When you do that, you really drain those batteries very fast. You probably have to have a huge bank of batteries, or like 10 to 15 batteries with huge, 400 watt solar panels to keep them up and charged. It's just not feasible to do that. There are, I didn't mention this in the program, but there are samplers out there there are refrigerated samplers that are designed to be portable like that, and will actually run run off of a battery. You're kind of limited on your time, but yes, there are portable refrigerated ones out there, and that's probably what I would do as opposed to running, a big refrigerated one with power. So.
Jeff, I don't know if you saw this. Doug added in regards to vandalism, they've had good luck with a large gel box type housings set into a frame that is concreted in, and then piping is laid below ground. That has worked well for them. Yeah,
any type of enclosure where they can't get access to any of that kind of stuff. Yeah, if the piping, your suction line that runs to the source, well, it's easy you can't really cover that up all the time. So if you can run that underground and conduit, that helps them from, tampering with that as well too. You just want to get it so they can't have access to anything like that. It's a very good idea. So pretty much however you want to do it and get it so nobody can touch it is usually okay. Here's one from Andrew. If 96 samples is the target and recommended minimum sample aliquot is 100 mils, it seems difficult to keep the volume below 80% of the capacity of your sample container. Now, there's different sizes. You can go 5-gallon containers. You can go 2.5-gallon containers on there. What you just have to, it really depends on the size of your container. You know, 96, if you're taking 96 samples, 100 mils, you know, that's going to be just below a 2.5-gallon container. So that's usually, you know, okay. There is a little bit of plus or minus on, you know, every time it takes a sample. Sometimes you get a little bit more, sometimes you get a little bit less, but usually that's not enough to go over that. If you find that you are overfilling or you're getting too much sample, well, then you can either drop the number of samples, go down to 90 samples, or you can say, okay, I only want 95 milliliters every single time it takes, you know, for the aliquot. You just have to kind of play around with it and get it so, you know, it works for all situations for you. It can be difficult. A lot of times it's trial and error. So most of the time when you're doing the composite samplers, you take the tubing and you run it directly into the bottle. And then on the purge cycles, it's actually taking water out of the bottle and then purging it back out if the bottle gets full. So most of the time you really won't overfill your bottles in those situations, but it is possible if you have if you're taking lots of samples. Here's one from best advice for washing portable samplers and tubes between collections. The tubes, pretty much washing the tubes and stuff, it's a wear item. Pretty much we don't wash those unless, you know, until they wear out, until they split or something like that. We don't really wash the tubing and stuff. For actually the sampler, pretty much we just, you know, warm soapy water is really the best, you know, for what we do. Simple green is always good for like contaminating and stuff like that. It's a good thing. If you're using other chemicals, you probably want to test in a spot that, you know, that's inconspicuous, and just make sure it doesn't melt the plastic or, you know, discolor the plastic or stuff like that. But simple green works very good for decontaminating and cleaning as well. So. Should any gaskets O-ring be greased prior to replacing? That again is model manufacturer dependent. We do put grease on a lot of our O-rings and stuff like that. A lot of times we use that just to hold it in place. If you're putting grease inside the actual peristaltic pump, we do not recommend that. Some people say that it will actually help their pump tubing last longer. Most of the testing we have done has said no, that actually is the opposite. It actually makes the sampler perform worse, and it usually breaks down the tubing and it doesn't last as long. So no grease in the chamber, but yes, I would usually put grease on the O-rings. But again, that's probably more model make specific. What if I need to take samples 32 feet deep? Is there any model which can do that? So no, it's actual physics things. It's the law of physics that you can only pull a sample up with a vacuum 32 feet. It's not, there's no sampler out there that will actually pull it higher than 28 feet. It's just a physics thing. So we just can't do it. If you need to do 30, if you have one that's 32 feet deep, then that's what I said before is the booster pumps. So you have a booster pump that's down below less than the 32 feet, and it sucks the water up to the booster pump. And then from there, it pushes the water up to the top sampler. So really the only way if you have to go over 32 feet is to have some type of booster pump down below. You could also do like a flow through chamber, you know, down at around 20 feet or 25 feet, somewhere in that range. You have a flow through chamber at that point, and then you run your suction line down that far to that, and then you sample with the flow through chamber. There are electrical pumps that will actually pump the water up higher than that. So you have the electrical, like a sump pump down low, and what you're doing there is you're pushing the water up, and there you're pretty much unlimited. You can push that as high as you want, but when you're pulling it with a vacuum, you are limited to 28 feet. So. Types of tubings that are available for ISCO samplers. The two main tubings we have are vinyl, which is like a clear type stiffer tubing, and Teflon. Teflon's an actual name brand type tubing. It's actually a flicker, kind of a milky white tubing, a little bit harder, more rigid. It keeps, anything from basically from sticking to it. Those are the two main types we have: Teflon and vinyl. The vinyl is by far the most popular. If sampling in a manhole, can you mount a modem as well as other attachments modules to the sample, or special brackets needed? However you can get it to mount in the manhole is fine. There are spreader bar types things that hook on the lips of the manholes that you can hang things from. I've seen people drill holes and put anchors into the side of a manhole and then just have cabling and hook it right to there. If the ladder is in good shape, you can actually anchor it to the ladder. I'm always cautious about that because they tend to rust and everything. But as far as a modem, yes, you can put modems in a manhole. It is below grade. Sometimes you can have reception problems and stuff like that. But there's different antennas you can have that actually you can bury in the street. There's some that'll actually mount on the top of the manhole lid. There's some even that mount underneath in there too. And just depending on signal strength in your area, yeah, a lot of times you can have a modem in there, and it usually works just fine. We have a lot of flow meters that have modems on them that will actually be in manholes like that. So yes, that is very possible to do. And really, however you want to hang it in there is usually fine. Oh, 5800 has bottle number output. Why with 306 Tynet? If you have, they're talking about the bottle output numbers. If it's Y, that always say number 1 on the screen for the signature. That is usually because if it's in a composite mode, it just means it's taking the sample. It doesn't keep a number of the samples. If you have it in the 24 bottle, it usually tells you what bottle that it is that you're taking it on there. So, but more, give us a call on that number for a little bit more, in depth on that one if you have more questions on that. So, next one. Another one talking about more about the PFAS sampling. Again, I would talk with your chemists and stuff on that. They're going to have a lot more information than me on that type of stuff. What are the most overlooked preventative maintenance steps? That one is changing your pump tube. You definitely, in the peristaltics, you want to change that pump tube before it breaks. Most people just go until they don't get any samples anymore and they start pumping water all over the place. Yeah, that is number one. I mean, you can get away with doing, the only maintenance you want to do is change that pump tube. You can get away with just that. You want to clean the inside of the housing and stuff like that. That's another one that gets missed a lot. You'll get rubber buildup on the pump rollers and stuff like that. But yes, you make sure you want to change that tubing before it breaks. A lot of models actually have a warning that comes up that says, hey, you've reached your pump count limit. You probably want to look at replacing that tubing. If you don't replace your tubing and the tubing breaks, you can actually force water into the sampler sometimes, and that can sometimes ruin the samplers, and you're looking at high repair costs for that. So definitely change the pump tube when that warning comes up. Change it before it breaks. Another one, sampling from pressurized lines. Yeah, it's basically, you can sample from pressurized line. You have to have some type of pressure reduction valve. It takes the high pressure and goes and reduces it down to something that the actual peristaltics can handle. Most samplers will hold back anywhere from 12 to 15 psi. That's all determined on the pinch point where that roller on the peristaltics actually turns and pinches that tubing. It's like a physical thing that's holding it back. So if you're over that 12 to 15 psi, then you usually have to do the pressurized line system. Vacuum samplers, on the other hand, you cannot have pressurized of any kind with a vacuum sampler. There's just no means to stop it, and it would continually pump into your bottle. So. Actually, one of our guys here gave me an answer to one of the PFAS questions. It says, the PFAS, have been found to absorb to glass, especially when the sampler is in contact with the glass for a long period of time, being stored in a glass container. If the sample comes into direct contact with the glass for a short period of time, e.g. use a glass container to collect the sample, then transferring the sampler to a non-glass bottle, the absorption is minimal. So basically just the exposure rate. You don't want to, if you have to use glass, just don't let it sit in the glass very long. So thanks for that, Kelsha. Are the telephone modems 3G or 4G? So the modems we have now, the ones that are going out there now, are actually 4G LTE. Verizon is a main carrier for a lot of those, and Verizon is actually getting rid of our older modems were actually 2G service. Some of the G modems were actually 3G, but most everything new nowadays is going to be a 4G LTE type modem. If a portable sampler is being used at various locations and for different effluents, can the suction hose be washed between uses and reused to sample a different effluent? If so, how do you recommend washing the suction hose? I do not. I recommend, if it's a different application, I would recommend just new suction line for that. I never recommend, same with the pump tube too, I would recommend new, when you're switching from application to application, new everything. So another one here about modems. Can you use AT&T with the modems? Yes, the G, we have C modems and G, so Charlie and George modems. The G modems, yes, they can be used with AT&T. If it's a C type modem, then that has to be Verizon, and that again is just the ISCO equipment. You know, other manufacturers, you'd have to talk to other manufacturers to be sure on, you know, their modems and stuff. Anything you see I missed there, Sharon?
No, it looks like you've covered the questions. If you've had another question that wasn't answered, please feel free to call the number that Jeff did provide, and one of our specialists would be happy to further assist you.
There's also an email address if you'd rather do email. You do ISCO EPS at Teledyne.com, and that's ISCO, and then Echo Paul Sam for EPS, and Teledyne is TELEDYNE.com. So ISCO EPS at Teledyne.com is a good source, as well as that number, which is 866-298-6174. And I think we're good.
Okay, well, thank you everybody for attending our tips and tricks for water samplers webinar. And thank you to Jeff for presenting on this topic. As many of you are aware, a lot of us are working outside of the office, and we greatly appreciate your time in joining us. This was recorded, and a video will be made available. And as mentioned, if there's further questions, please feel free to reach out to me through Zoom, and I'll forward it on to Jeff or another one of our specialists. Thank you again for joining us. Stay healthy and have a great rest of your day.